In this video, we'll discuss about zookeeper basics. Several primitives used for coordination are commonly shared across many applications. Consequently, one way of designing a service used for coordination is to come up with a list of primitives, expose calls to create instances of each primitive, and manipulate these instances directly. For example, we could say that distributed locks constitute an important primitive and expose calls to create, acquire, and release locks. Such a design, however, suffers from a couple of important shortcomings. First, we need to either come up with an exhaustive list of primitives used beforehand or keep extending the API to introduce new primitives. Second, it does not give flexibility to the application using the service to implement primitives in the way that is most suitable for it. We consequently have taken a different path with Zookeeper. Zookeeper does not expose primitives directly. Instead, it exposes a file system like API comprised of a small set of calls that enables applications to implement their own primitives. We typically use recipes to denote these implementations of primitives. Recipes include Zookeeper operations that manipulate small data nodes called Z nodes that are organized hierarchically as a tree, just like in a file system. And here this figure illustrates a Z node tree. Here the root node contains 4 more nodes and 3 of those nodes have nodes under them. The leaf nodes are the data. The absence of data often conveys important information about a Z node. In a master worker example, for instance, the absence of a master Z node means that no master is currently elected. This figure includes a few other Z nodes that could be useful in a master worker configuration. So the first is the worker's Z node is the parent Z node to all Z nodes representing a worker available in the system. This figure shows that one worker, that is foo.com:2181 is available. If a worker becomes unavailable, its Z node should be removed from workers. Then we have the task Z node, and it is the parent of all tasks created and waiting for workers to execute them. Clients of the master worker application add new Z nodes as children of tasks to represent new tasks and wait for Z nodes representing the status of the task. And then we have assign Z node, and it is the parent of all Z nodes representing an assignment of a task to a worker. When a master assigns a task to a worker, it adds a child Z node to assign. And that was all about the Zookeeper basics.